Hello, today we're going to talk about colligative properties, and a colligative property, sorry, just to give you a definition, is any property of a solution that changes when you dissolve a solute in the solution. So the solute is the stuff that we're dissolving. In this picture here, it would be the little pink particles that are in there in addition to, the water molecules or whatever our solvent is. Right. So, there are a lot of different colligative properties. The two that we're going to talk about are freezing point and boiling point. Freezing point is the same as melting point, right? The temperature at which something melts is the same as the temperature that it freezes. So usually I say freezing point, but you can use them interchangeably. So if we have a sample of water and we add salt to it, for example, it gets in the way of the water molecules. All right, and then as a result, those water molecules can't form the interactions they need to in order to become a solid. So you have to make it even colder in order to get it to refreeze, all right? So we basically have to get it cold enough that we push those salt molecules or ions out of the way so that the water molecules can refreeze. All right, the other one we're going to talk about is boiling point. And when you add a solute to a solvent, like water, for example, the boiling point gets higher. So basically, the individual ions or whatever particles you've dissolved interact with the water molecules, right? And they are attracted to each other, and therefore we have to heat it more in order for those solvent molecules to escape into the vapor phase, which is what happens when we boil. It goes from a liquid into a gas. All right, so each of these properties is affected by how much solute is there. And it doesn't matter what the solute is, it's the number of particles that are there that makes a difference. So if you have a non-electrolyte, you only get the number of particles you put in, right? Because they don't split up at all. If you have a strong electrolyte, it would potentially split up into multiple particles, and you would be able to then, each of those would either get in the way or attract these solvent molecules and cause a change in colligative properties. Look at the example we looked at in the electrolytes video, sodium chloride. It splits up into two particles when we dissolve it. It dissociates, right? So this would have the impact of 2 times as many NaCl's as we actually added. If you had an ionic compound that was a strong electrolyte that had more than 2 ions, so for example, AlCl3 has 1 aluminum ion and it has 3 chloride ions, so you actually get 4 particles when you dissolve one of those, and so that would have an even bigger impact. Whereas if we had a non-electrolyte, you would see that, if we dissolve sugar and it's now dissolved, it's still just 1 particle. It doesn't break up into pieces. It doesn't matter that there are, 24 atoms there. They stay together as 1 piece, and so they just have the impact of 1 particle. All right, and in between the strong electrolytes here and the non-electrolytes here, we'd have weak electrolytes. So depending on how much they dissociate, that would tell you how much of an impact they're going to have. We mostly in this class are just going to look at electrolytes versus non-electrolytes, basically salt versus molecular compounds that don't dissociate.